It's my pleasure to introduce Paul Braden. Paul is an electrical engineer with the Air Force, and he's going to talk today about how the Air Force measures efficiency in their software engineering programs. So,
thank you. Thank you very much. So I do need to preface this. How many people here have worked on government contracts? Okay, a whole bunch. All right. As per usual, there is a disclaimer that everything in these slides and everything that I will say is not reflective of the U.S. government or any other forms of authority that would have power over me. So this is solely my perspective. Take it and use it for your advantage as software developers out in the industry world who have to work with government. Personally, I feel very sorry for you because I know that we are a little bit hard to work with, and I hope that this will kind of ease any work experiences that you might have going forward. So having said that, this is kind of the agenda. I promise you it's not going to be dry and boring. I do have a YouTube video to wake you up. So for an introduction on myself, I am an electrical engineer. I do software, but I'm mostly an innovator and try to think outside the box of the typical person that sits at a computer and writes code all day and trying to say, hey, we can make this better if we did this. So my background is aerospace engineering, and I did modeling for rarefied hypersonic flows and trying to optimize space re-entry vehicles. And then they picked me up out of that and put me in the software world and were like, hey, you need to help these guys with their codes for the B-2 bomber. And I'm like, I don't know anything about the B-2 bomber. So if there are things that are a little hard for me to understand with your questions at the end, just bear with me. I do have a little bit of a different background. The big thing that I do want to get across is I have a for official use only document that I have on my laptop, my Air Force laptop here, and it describes in detail the U.S. Air Force AFSC way, which is the fundamental document that dictates the life of a software developer for the Air Force. And so I'm going to dive into that so that hopefully anybody that wants to know basically my views on what does the AFSC way say. A lot of people have access to it depending on what their contracts are. But the big thing that you're going to get out of it is we use CMMI and agile very heavily. And I'll explain why, and it comes directly from the documentation in AFSC way. And then I'll present some of my efficiency studies that I did at Tinker and my productivity studies. And then I'll be happy to take any questions. So here's the YouTube video as promised.
Our company has a new strategic initiative to increase market penetration, maximize brand loyalty, and enhance intangible assets. In pursuit of these objectives, we've started a new project for which we require 7 red lines. I understand your company can help us in this matter.
Of course. Walter here will be the project manager. Walter, we can do this, can't we?
Yes, of course. Anderson here is our expert in all matters related to the drawing of red lines. We've brought him along today to share his professional opinion.
Nice to meet you. Well, you all know me. This is Justine, our company's design specialist. Hello. We need you to draw 7 red lines, all of them strictly perpendicular, some with green ink and some with transparent. Can you do that?
No, I'm afraid...
Let's not rush into any hasty answers, Anderson. The task has been set and needs to be carried out. At the end of the day, you are an expert.
The term red line implies the color of the line to be red. To draw a red line with green ink is, well, if it's not exactly impossible, it's pretty close to being impossible.
What does that even mean? An impossible
It's possible there are some people, say, suffering from color blindness, for whom the color of the lines doesn't really make a difference. But I'm quite sure that the target audience of your project doesn't consist solely of such people.
So in principle, this is possible.
I'll simplify. A line as such can be drawn with absolutely any ink, but if you want to get a red line, you need to use red ink. What if we draw them with blue ink? Still won't work. If you use blue ink, you'll get blue lines. What exactly did you mean when you talked about the transparency?
sure you know what transparent means.
Yes, I do.
And what a red line means. I hope I don't need to explain to you.
Of course not.
But you need to draw a red line with transparent ink.
Describe what you imagine the end result would look like.
Come on, Anson, what we got here? Kindergarten.
No, I'm just trying to get a
Let's not waste our time with these unproductive quarrels. The task has been set, the task is plain and clear. Now, if you have any specific questions, then go ahead.
You're the expert here.
All right, let's leave aside the color for the moment. You had something there also relating to perpendicularity.
7 lines, all strictly perpendicular.
To what?
To everything amongst themselves. I assumed you know what perpendicular lines are like.
Of course he does. He's an expert.
2 lines can be perpendicular. All 7 can't be simultaneously perpendicular to each other. I'll show you. This is a line, right?
Yes.
And another, is it perpendicular to the first line?
Well,
Yes, it is perpendicular.
exactly.
Wait. The third one, is it perpendicular to the first line? Yes, it is. But it doesn't cross the second line. They're both parallel. Not perpendicular.
Suppose so.
There it is. 2 lines can be perpendicular.
Can I have the pen? How about this?
This is a triangle. It's definitely not perpendicular lines. There are 3, not 7.
Don't want to ask that myself.
I have a blue pen with me. This was just a demonstration.
That's the problem, your lines are blue, draw them with red ink.
Well, how do you know before you've tried? Let's draw them with red ink, then let's see.
I don't have a red pen with me, but I'm completely certain that with red ink, the result will still be the same.
But didn't you tell us earlier that you could only draw red lines with red ink? In fact, yes, I've written that down here. And now you want to draw them with blue ink. Do you want us to call these red lines?
I think I understand. You're not talking about the color now, right? You're talking about that what do you call it?
Perpendicularity, yeah!
That's it, you've confused everyone. So what exactly is stopping us from doing this?
Geometry.
7 red lines. It's not 20, it's just 7. Anderson, I understand you're a specialist of a narrow field. You don't see the overall picture. But surely it's not a difficult task to draw some 7 lines.
Exactly. Suggest a solution. Now, any fool can criticize. No offense. But you're an expert. You should know better.
Okay. Let me draw you 2 perfectly perpendicular red lines. And I will draw the rest with transparent ink. They won't be visible, but I'll draw them.
Would this suit us? Yes, this will suit us. Yes, but at least a couple with green ink. Oh, and I have another question, if I may. Can you draw one of the lines in the form of a kitten?
What?
In the form of a kitten. Market research tells us our users like cute animals. It would be really great if we could.
No.
Why?
Look, I can of course draw you a cat. I'm no artist, but I can give it a try, but it won't be a line anymore, it'll be a cat. A line and a cat, these are 2 different things.
A kitten. Not a cat, but a kitten. They're little, cute, cuddly. Cats, on the other hand,
It won't make a difference.
Anderson, at least hear her out. She hasn't even finished speaking and you're already saying no.
I got the idea, but it's impossible to draw a line in the form of a cat.
What about a bird?
So, where do we stop? What are we doing?
7 red lines, 2 with red ink, 2 with green ink, and the rest with transparent. Did I understand correctly?
Yes.
Excellent. In which case, that's everything, right?
Oh, I almost forgot. We also have a red balloon. Do you know if you could inflate it?
What do I have to do with balloons?
It's red.
Anderson, can you or can you not do this? A simple question.
As such, I can, of course, but...
Excellent. Organize a business trip. We'll cover the expenses, go over to their location, inflate the balloon. Well, this is very productive. Thank you all.
Can I ask you one more question, please? When you inflate the balloon, could you do it in the form of a kitten?
Of course I can. I can do anything. I can do absolutely anything. I'm an expert.
There we go. So I figured that that would be a good way to introduce this topic, because a lot of what we do is fight management that tells us what to do. Now let's see if I can get out of here.
What's the URL?
It's posted on my slides. I'm sure that we can make sure that it'll work. So as you can see in the video, there's a lot of definitions that get thrown around. There's a lot of arguments between management, the actual engineer, the people doing the marketing, the people doing every aspect of producing the product. So why are we here at this conference, and what kind of background are we coming from? Are we the people that make the charts that predict what's going to happen? Are we the people that work on radar plots like this, where we're like, you know, this is how the organization looks as a big picture? Are we the people that prevent errors from happening, especially stupid ones? Are we the people that just write lines of code, and lots of them if we can? Or are we the quality control people? Are we the ones that have to say, no, you can't draw a red line with blue ink? I would argue that management wants us to be the people that get everything done, especially for the Air Force. Like I said, this is all personal view, but it has a lot to do with what's important to the Air Force, and what it comes down to is they want you to do everything as quickly as possible all the time. So this is what I'm going to talk about, is efficiency and productivity in the Air Force. And when you think of efficiency, we, as engineers, like to do flowcharts or plans that make sense to us. And how do we relate that information to something that management would understand, and back and forth? And that's why they invented the AFSC way, which is what we're going to talk about. If I could summarize the AFSC way in 3 words, this would be it. And it actually is in the title of the AFSC way. It goes, AFSC way, speed is good. So this is the AFSC way. If nothing else, that's what you need to know about the Air Force and software engineering. In fact, if you work with the government in general, that's probably what you need to know. So the term speed is a very elusive term, because it encompasses a lot more than just doing things fast. So this is the definition in the AFSC way lexicon. I'm going to break it down real quick, because it sets the basis for what we're going to talk about. Efficiency, productivity. So both of those go into that speed part. The paced. When we think of paced, we're thinking agile. And then the road to the goal, we define that using CMMI, because ultimately you're going to get ranked, and we want to be the best, and the ranking is what tells us if we're the best. So that's where CMMI comes in. But what's interesting is there are overlap, and when we look at processes, we think both CMMI and agile, and so we kind of blend them. So these are some important definitions. I'm not going to tell you what they are, but if you do have any questions about them as we go along, I'd be happy to. Like I said, I have the document up and ready with all the formal definitions. But the kind of key ones that I would point out are the gates. There's 7 gates that we work with. So when you start a software project and want to produce something in software world, you have to do these 7 gates, period. I'll show you them, and we can definitely talk more about them. And then the other one is touch time. The Air Force measures everything in touch time, how much time you actually spend writing code. That's pretty critical because there are things like bookkeeping time when you have to like do documentation, which we also consider valuable, but it doesn't fit into the grand scheme of speed is good. In fact, generally speaking, speed is good means more touch time. So it can hurt and it can help, but that's an important definition to make. So critical path. I used an example. It's kind of cheesy, but let's say you wanted to walk from the airport here. This is probably the fastest way to get here. Some people, though, like myself, will go to the zoo first and then come here. Is that a critical path? No, but it sure is a nice one if you're trying to see San Diego and spend some time outside. The overall rule that we use in the AFSC way is Little's Law. And it has a lot to do with the theory of constraints, which says that there is going to be a bottleneck in any process at which if you improve that bottleneck, you will improve the rest of everything else. Otherwise, if you're improving other things, that bottleneck is still going to determine how fast you produce stuff. Little's Law, it's important in the terms of productivity. It's more on the productivity side with the throughput and flow time. But as far as efficiency goes, that's where the theory of constraint comes in and says you need to improve this. So why did the Air Force start the AFSC way? There's been several botched software programs that I've gone through, costing several billions of dollars. And we've been trying to avoid that going forward. So that's why our 4-star general put this on us rather recently, actually. So now that you understand the baseline CMMI and agile place in the AFSC way, let me just kind of refresh on what we see CMMI and agile. This comes straight from both sources, so it's not anything new, but it's not a battle like the boxers for us. I just wanted to clarify that. So CMMI, there's 5 levels, obviously. The one that the Air Force personally operates most of the time at is the defined level. We have processes, we have them defined, but we don't really work too hard on optimizing them because if you're doing them right and you're getting it done, that's good enough. And we just want to make it go faster. We don't necessarily care about optimizing the process and putting more software engineers on a program. We try to find other ways to make things work. So coming from that perspective and looking at agile and saying, okay, we're mostly in the defined range. For defined, we use this. We don't really work. I mean, we of course try to optimize, and we've been several of our units, the Hill Air Force Base and Warner Robins, as I'll show, were CMMM level 5. And so they're considered to be optimizing and doing that workload. So it depends who you talk to. When you're in it and working it, it seems like it's more on the defined level, though. So agile, here's the kind of breakdown of how it works. We do the daily scrums and work very hard with the actual producers of the code, the architects, and try to make sure that they're producing what we need as quickly as possible and have all the roadblocks pushed out of the way. So now that you know that, so like I said, Air Force uses CMMI as the evaluation tool and the standard across the board. Agile, though, is more of the process. There are aspects of both in the process. So this is from the CMMI SEI paper on CMMI or Agile, why not both, embrace both. And it's just kind of listing the advantages of CMMI and Agile. So with Air Force projects, they tend to be large scale more than small scale, but there are several things with the volatile requirements and other aspects that you have to take into consideration. So efficiency is the first thing I'm going to define. And this is the definition. It is a relative efficiency, and it's be better than everybody else in the Air Force. Basically what it boils down to. And that idea is summarized in the acronym MEO, most efficient organization. So if you are the best, you will get the money, and you will become even better, and everybody else will try to become like you. So it doesn't necessarily mean that your internal processes are the most efficient. It means that you're better than everybody else. Okay? That's a huge point, because in our world, our competition is Hill Air Force Base and Warner Robins at Tinker, and vice versa. They're trying to beat us. So this is when I was working there. This was the current ranking. Was Hill Air Force Base and Warner Robins were both CMMI level 5, and Tinker was level 3. And they like to display that. So this is the homepage for Hill, and it says, we are a CMMI level 5 organization. And then Warner Robins actually even released some of their data and let people produce charts like this and say, hey, look how good we got after we became CMMI level 5. So this shows the schedule variance, so you can see that they were more than 400 days off on some projects in their scheduling. But after doing CMMI level 5, now they're all very clustered, and they have pretty accurate predictions. On the other hand, when this is from Tinker, on the other hand, with Tinker, we kind of been producing results as well on our own and looking at efficiency and productivity and kind of saying, okay, for our hundreds of programs which are on the right, the primary workloads, these are kind of what it looks like for our cost variance and schedule variance, which I'm going to describe now, which goes into earned value management, which is a part of that agile, and the idea that, you may save money, but if you're also saving time, or if you're spending more money and saving time, that's still good. So we do capture that. So it's an overall return on investment. I am kind of running low on time, but I'll just kind of briefly go over my efficiency study that I worked with the guys at Tinker on. So this is we have 4 different rankings for a program when it goes through the software development system, and it's either simple, it's average, it's complex, or it's very complex. So this is for the simple. You can see these are the different gates, and these are the different amount of flow days that we assign to each gate. V and V stands for verification and validation, so I just abbreviated it for fitting it on here. And this is kind of the Excel spreadsheet that you can run to pull the data and say, hey, this is where our bottleneck is, and this is what we're looking at for our total deliveries. When you run it, obviously I'm not going to be able to run it from this computer because I don't have all the stuff on it, but when you run it, this is what you're going to look at. What we came to was when we induct something in, on average, we should look at about 383 days for turnaround. So that's kind of what we were looking at. And what you'll find most interesting, and this is why I'm here talking to you, is this manufacturing part right here. This is you guys, the external hardware, software people that we have to go out to do the parts of the coding and parts of the design that we can't do internal house. That's where our bottleneck is, consistently. Sorry, guys. So, if you guys do better, we do better. Exactly. So anyway, I just wanted to show that. I thought it was interesting because it explains a lot of where contracts and failed contracts can become a problem. So I don't have a lot of time to talk about productivity, and I really don't want to because it's a lot of very, very intense words. This is all going to be up there, but basically a lot of other organizations, I use IBM as an example, have software just designed to measure productivity. We technically don't have the same level of expertise in that area, but what we did find, and what I'm going to present to you, is out of those 4 areas that we've defined, the simple, average, complex, and very complex, what we found actually, and which a lot of people might be surprised by, is these are the number of flow days that we predicted that it should take. what we actually found was the very complex was actually fewer flow days than the simple. How did that happen? And what you'll find is we put the best people on the very complex. We put our best software guys on the very complex, and they were able to produce it faster than the people that hadn't been doing it for a long time and were working on the simple ones. So that's just a thing that you can't put into your predictions. So we did one-way ANOVAs, and that's how we came up with that result. So conclusion, efficiency is dependent on most efficient organization. Productivity depends a lot more on the quality of the programmer than on the complexity. So the better the programmer, the more production you're going to have. Not necessarily the easier the project, the more production you're going to have. And finally, we use both CMMI and agile as a means for measuring success. Any questions? Yes?
Just wondering, you guys use open source software when you build your tags? If you do, what kind of validation do you do before you decide which open source?
Right. So we work a lot with Excel. We do. So I have been working with Minitab, SPSS on the optimizing side of the house with like looking at our processes and trying to get that done. But other than that, mostly Excel. So.
I have two observations. You were talking about the ANOVA analysis thing, so you're applying statistics to your process to get see where your weak points are and so on.
Yeah.
Okay. Also, I noticed when you had the blocks of time out there that for the verification and validation, you had 1 day, as I recall.
Yeah.
That seemed odd to me, because usually that's in our environment. Granted, we have some work to do on it, but we have two separate groups, the verification group and the validation group. And the validation can be as much as the entire,
Right.
or a big chunk of the whole development process.
I wish I could give you a good answer about it.
Yeah, I was just wondering how you pulled that off.
Well, to put it simple, I really can't give you a good answer on that. I do know that across the board, whether it's simple, average, complex, or very complex, we only give 1 day, 1 flow day. So it doesn't matter what the program is. So it is scrutinized. It is scrutinized throughout the whole process.
Okay, so that may be the answer. You're leveraging automatic testing along the way.
Correct.
With the confidence of that, which is one of the things we're lacking. We don't have.
Right, and we're very fortunate in the sense that everything that we're developing code for, we have the planes right there to put it on, and whatever we need to do, and we have all the testing right there in-house, and it's extremely easy.
Tests on the jets as you're.
We do a lot of we do a lot of back and forth with that. Correct. So, yes.
Curious as to your accountability model for private sector. So, for instance, I believe it's Lockheed Martin making the F-35 fighters, looking right behind $400 billion plus in excess.
Yeah,
How do you make them accountable?
that's way above my pay grade. Honestly, with what I've seen with software development with the Air Force, and again, like I said, this is all my views that I'm presenting. Anything that involves lots of money and lots of visibility like that is being reviewed by Congress, and that is way out of our hands.
So the groups, to be fair, the groups that Paul works for software maintenance teams or systems maintenance teams. They basically do the maintenance on airplanes, not the new development.
Right.
So the questions related to the F-35 should probably go to the F-35 program office.
Thank you.
And
yes, sir.
I just got to keep my speaker clean.
Talking about the difference in productivity between what you termed as the best developers versus newly hired or less experienced. I mean, how are you basing that judgment? Were you quantifying the number of years of experience or some other measure to?
Right. So actually, what everybody knows everybody in our organization, which is a great way to keep things. So yeah, you can usually tell like, oh yeah, we assigned that to Phil, and Phil, you know, is pretty good at this stuff, and he's been doing it for a while. So yeah, he's going to get it done a lot faster. So I really can't answer that too much better than that, but it's mostly just because we're a very close-knit community. So with us, like I said, we have a very large workload, but I'd say maybe 40 engineers. So, thank you.
All right, thank you very much, Paul.
Yes.